Hello everybody and welcome to another video of Python Basics. So today we are going to be talking about input and output. We already kind of talked about output with the print statement, but we're going to talk about input and output in terms of files and also input in terms of typing in information from the terminal. And then we're also going to be introducing you into conditionals, which are also known as the if statement. And finally, we'll actually start by talking about concatenation, which is one of the uses of the plus symbol that we didn't talk about when we were talking about operators last time. So yeah, let us go ahead and start out with that actually. So last time we were doing, a list of all the operators, and we did conditionals, we did comparison-based operators, we did arithmetic operators, and we even played around with logical operators and, or, and not. And so basically what I want to do is just add one more usage of the plus sign. So the plus sign, when you're working with numbers, means to add them together, addition, right? And we also saw that if we try to add something like a string and a integer together, we get an error. Okay. However, it turns out that if you try to add two strings together, you don't get an error. You get some rather interesting behavior. So let's go ahead and do that. So let's create a var1, and actually let's just put numbers first, just to confirm that addition is indeed happening. So if I say print var1 plus var2, we get 7, right? Great. Okay. Well, what happens if we now go ahead and say, 2 like that, but with quotes? This is no longer an integer. This is now a string. In fact, actually, that's almost a car because it's a single one, but okay, doesn't matter, either or. So, try to do my addition and I get an error, right? I get an error that says that you're trying to basically concatenate. See this word concatenate? String to another string. So it's complaining that I'm trying to concatenate this with an integer. And if I flip this around and put this back to numbers, but then put this in as a string, now I get a different kind of error that says the one that we got last time, which is unsupported operands for the plus operator for int and string, right? So it doesn't like it either way. However, if I go ahead and do both, and I do this, look at this. I get 2,5 back, which looks like 25, and you're like, wait a second, 2 plus 5 is 25? Well, again, it's not representing it as an integer. It's representing it as a character, and a string, actually, in this case, technically. It's representing it as a string. And so, what it's doing, what concatenation does, is it actually puts both strings, the left and right operand, together, and just glues them together. Append them together, or concatenates them together. That's why it's called concatenation. It just happens that in this case, there are two characters that represent numbers, 2 and 5, and that's where you get 25. But if I put in here something like hello and world, and I concatenate them together like that, then I get hello world back. Now, of course, I don't get a space, so if I put a little plus in one of these, then I get hello world, okay? So that's concatenation for you. And that's one that I didn't show you last time, but it's important to know. So, concatenation. It's a binary operator that is going to take whatever's on the left and whatever's on the right and literally put them together. Like that, okay? That's what concatenation will do, okay? So it's very, very useful whenever you're trying to create a string that is like made up of different parts. So for example, you're doing data analytics and you are processing a file, and at the end of the program you want to say that the file contains this number of entries and this number of subjects or something, right? So what you would do is you would format your output, and then you would concatenate it all together into one big string, which then you print out, which looks pretty, okay? So Yep, that's concatenation, and I just wanted to make sure that I actually threw that in. So we'll practice it a while, but it's very, very useful, okay? Okay, so now to the interesting thing, which is the I/O. So I/O stands for input output. And you typically just like say I/O to just represent kind of like how do you feed information into a program and how do you extract information from a program. And typically when you think about output, you think about two locations where that output is going to go. That output is either going to go into the STDOUT or it's going to go into a file. Now what is this STDOUT? STDOUT stands for standard output. And this usually represents the terminal, which is where you're running your program. A file is literally just a file, like some piece of document somewhere in the computer that you want to write information to. You can create it from scratch or you can append to an existing document as well. Okay? So let's talk about standard output first. You've already done this. How do you communicate to the terminal? Well, we have been doing it all along with the print function, right? So when you say print hello world, this tells the computer, hey, go to the terminal, whatever the program is running, and print out this content, whatever you pass in as your parameters, okay? Very cool. What about the file output? Well, the file output you can do using a function, and I'll show you that in a minute. And for the input, there's going to be the same thing. So actually, I'm going to do that one down here. So again, for input, you can read from two places, really. You can read from a file, which again, we'll be using just like there. We're using that sort of same library. And you can also read from your terminal. So, you know, back in the day, 90s, early 90s, or late 80s, I guess, when you know, home computers were becoming popular, most of the programs that ran in something like Microsoft DOS, MS-DOS, were terminal-based. So you would type something into the terminal, it would do some computing, and it would come back. And you even had games like this where, you know, you like enter like, okay, which maze would you like to go into? You go into this maze and find this. You see two doors, which one do you take? One or two? And you press like, I take door 2. You have found this place. Now you see 3 doors. Which one do you take? And so on, right? So you'd have this interactive output, this interactive program that would have output, which would then take input, and then you go back and forth, and you go through this thing. To be able to do that, you need to be able to read information from the terminal that the user types, and then your program will act accordingly. When we talk about the if statement later on today, you'll see how you can actually modify the execution of the program control flow of your program based on what the user enters, right? That's if statement. But just in general for now, I'm going to show you examples of being able to read input from the user and at least store it somewhere, okay? So that we can process it later. And similarly, for both input and output, I want to show you how to read input from a file and how to write output to a file, okay? So let's start with the standard input, okay? It's actually really, really nice and easy. And I will put in the description below a link to the Geeks for Geeks for the input function, because that has a lot of examples. But in general, Python does this really nice when you just want some basic input, right? And actually, there is technically 1/3 thing for input here, which is your command line arguments. I guess I kind of forgot that one. However, we will come back to this one because I would rather us learn how lists work first and then actually explore this, because this is actually a list of stuff. So there is 1/3 input format that we will talk about later on, but for now, just be aware it exists in case you ever run into it before that, okay? But yeah, going back to standard input, turns out that you can use in Python a very nice function in Python 3 called input. So just like you have your print function, you have your input function, okay? And this, unlike well, not online, because print, I guess, might have some value return. But this one, you want to take advantage of what it returns. So some functions, as the word, normally mathematically, a function is something that returns a value, right? So with print, you don't really do anything with the value that you get back if you return something, because you're just like, hey, print us, you send stuff to print, you don't care what happens, right? But with input, you do, because what you get back from input is what the user enters. So as an example of that, I'm going to do something, no, I was going to simplify it. No, I'll keep it this way. I'm going to create a variable, call it var1, and I'm going to assign what input returns, like that, okay? But then I'm going to print it out, like that, okay? Now I could have combined these two lines, and that's what I was thinking of showing you, by saying print input, but I think that might confuse you more than help you, so we'll get rid of that. Okay, but let's just do that and see what happens, because this is something you have to see to believe kind of thing. Okay, so let us go ahead and do our var1. We can actually reuse the same variable, well, we really shouldn't, but we will, and then say input. Okay, let's run the program. So now we get our hello world from the stuff above it, files, hello world, and now you can see that it didn't terminate like before, right? Didn't terminate. In fact, let me comment this out again for a minute. Run the program again. You can see it terminates because I get a prompt here, and I can type more in the terminal, potentially, right? I can type here. However, if I enable this, notice how it's just there. Might be blinking in your computer, but here it's just like that. Okay? I'll show you what that looks like on a terminal if I run it on a terminal. So if I do Python 3, let's do Python 1, which was the program from last time, you can see that, oh, Python 4. Geez, I'm going into the future here. There we go. It terminates, right? It terminates, and then we can type in again. So I can run the program again and so on, right? But if I type in Python 3, Python 2, which is the name of the file we're working on, I get this blinking thing, okay? Let me move it a little bit this way so you can see it. I get this mysteriously blinking thing. What is that? Well, that turns out that that's waiting for user input. And by the way, if you're ever stuck like this on your program and you want to terminate it, you can press Control-C. So that's Control-C like that, but actually hold both keys together by holding Control first and then C, and that'll terminate the program for you, okay? It'll give you some warning or whatever error, but that's fine. So if you're ever stuck in a program, you want to terminate it, Control-C, okay? That's Control, so hold the left Control key, and then as you're holding that, then press the C key. That's what that will do, okay? Very, very useful tip to know, especially when we get to looping and you're stuck in an infinite loop, okay? So, all right. So what is this? This is waiting for user input. So let me go ahead and type something in. So like, hello program. Press enter and the program terminates. Why is that? Because this thing is taking input, storing it into variable 1, but then nothing else happens, the program ends. So let's try something else. Let us try to print out what we store in and say something like, the input given was, and I could use a comma, but here, let's do our concatenation while we're at it. So we learned that earlier, right? Run this again, and now let's write the word potato. The input given was potato. Notice there's no space because of the concatenation, so I would have to add a space here. But by the way, let us try to put in 42 and see what happens. Oops. So 42. The input given was 42. Very cool. So I want you to notice two things about this. One is that, hey, this is how we store information from the user with the function input. Whatever you put in for input, it will return it to the user. It will store it in the variable, and then when we print it out, it's kind of returning it out to the user to see, right? But the second thing I want you to notice is that you're concatenating here a string and what looks to be a number. That should give us an error based on what I said earlier, but it's not. My prediction as to why this is happening is because it's being stored, even though it's a number, it's being read in as a string, so as words, characters. So there's a function in Python, I believe it's called type, which will return to you what type of variable something is. And then you just put the variable name as a parameter. So if I print this out, we'll find out what this is stored as. So let's start out by putting in a word, literally word. And it says class string. So this is a string. Cool. Start putting in 42, class string. So you see, I was correct. It is indeed reading it as a string. What if I wanted to make it an integer, by the way? There's another function that allows you to do that in Python. Again, kind of skipping ahead by showing you this, but it's good to know. That one is called, I believe, just the type of what you're trying to convert to, and then you just pass in the variable. So if I say, let's just say var 5 gets the integer version of var 1. If I do that, and then I go ahead and say print integer version, comma, or colon, and then I use a comma instead of the concatenation, because now it's going to be an integer. Otherwise, I would get an error. And I'll show you the error, but I want to show you first it working. But before that, let's also print out the type of it, if it really worked. If I run this now, put in 42, you can see that it starts as an integer, but then I do this var 5 gets int var 1, and it becomes an integer now. So now we're saying, okay, take this thing that's a string and convert it, or try at least to convert it to an integer. Succeeded, because we can see it's an integer now. But we can see that both of these look the same, because at the end of the day, the number is being printed as characters. However, if I try to concatenate it this time around, then I'll get the error, because this time it's actually concatenating an integer with a string, which is a no-no, okay? And also, just to show you what happens if I try to force a, oops, sorry about that. If I try to force a word or a string to be an integer, then I'm going to get another kind of error saying invalid literal for int with base 10. So what this is saying is that I'm getting this literal value, so this what should be a number, but it's not. And it's trying to convert it using a base 10, so meaning, because that's the other thing. You know, what if I'm feeding it a hexadecimal value? You know, in hex, the number 21 is not 21. It's a completely different value in hex. So it needs to know what base it is. If you don't feed it a base, it by defaults to just like decimal. So it's like, okay, 21 is literally just 21, right? But if you intend it to be something else, then you have to give that as an argument. So, you know, we'll explore more this int function later on. But what I'm really just trying to get to you is that when you're reading an input from the user, it's typically going to be read in from a terminal at least as a string. So if you intend to use it for mathematical operations, such as trying to add numbers together and whatnot, then you gotta convert it. And while we haven't really talked much in detail about functions and whatnot, just know that you can convert it using this. And it doesn't have to be an int, by the way. You can make it into a float. You type the word float in there, and so on. So I could very just as well say float in here, and then if I pass in 45. Oh, it's complaining because I'm trying to concatenate it still. So let me switch this back to a comma. Let's pass in our 45. And then we can see that, well, it says integer here, but it should say float now because we're making our float. And it likes to tell you that it's a float by putting in the dot part, even though it's a whole number. It's still like this is dot 0. This kind of gives you a hint like, hey, this is a float now. Just beware of that kind of thing, okay? So I guess we should change that to say that to make it nicer. So pass in like that. It'll be good to go. Okay? So that's how you're reading things. But of course, right now, our program is not very cool because it's like, it's just expecting the input. But like a truly interactive program should ask you in a nice way too. Be nice, you know. Should nicely ask you like, hello, sir. Or hello, ma'am. Would you like to please enter your number for your passport or something? You know, we would like to have a prompt. You know, and so how do we put a prompt? Well, there's two ways that you can put a prompt in here. Way one is you could literally put a print statement before your input function. That's how you typically do it in languages like C++. You write your prompt and then you write your input. So you could say something like, dear person, please enter your age. And then let's comment this out for now, except for this, and say you are years old. Have a nice day, or have a good day, or have a nice day. Random reference to YouTube, if anybody remembers what that is, where that's from. But yeah, so now this looks a little nicer. Dear person, please enter your age. So I'm like, okay, 48. You are 48 years old. Have a nice day. We're gonna put a space there just to make it nicer. Let's try that again. Let us say 10. You are 10 years old. Have a nice day. Now, do notice something. We have this is known as hard coding. We have hard coded the prompts. So if I say 1, it says you are 1 year old. Technically, it says 1 year old, right? Because we hard coded the word years. So later on, when we learn about if statements, we can go back and fix this. So that, like, if the number is 1, then I guess it's a special case where you say year instead of years because it's not multiple, right? It's an individual. So yeah, that's one way of doing it. Although Python has a much nicer way of doing this. It turns out that the argument that you can pass into your input function is actually the prompt itself. So I can literally take what I have here, put it in here, comment this one out, run it again, and I have achieved the same thing. In fact, this one's a little nicer because look at that. By default, it puts it on the same line, whereas before it was putting it on the next line. So let me show you what it looked like before and after. So see, that one's on the next line, whereas the other one's on the same line. Not that you can definitely modify the print function to do that. You just gotta get rid of the line feed that print generates after each print statement, which you can do with an argument very easily. But the point is that there's really no need in Python 3 to write a print before when you can just put that same content in your input function. Okay, it's really, really nice. I mean, think about it. You just gotta remember the word input, put whatever you want as your prompt, and assign whatever you get back into a variable so that you can do whatever you want with it later. You could, of course, just read it in immediately and throw it away, but like, what would be the point then, really? You want to store the data because you're probably going to use it later on. But yeah, I can just go in here and type in, and it says that, right? So yeah, that is your basic way of reading in from the terminal input. Now here's an issue with this. Suppose that you know, you're like, dear person, please enter this, and you're like, well, I am 23 years old. Like, you actually respond with more than just a number. Now it says, I am 23 years old. Have a nice day. So as you can see, it literally inserted the entire statement in there, right? That's not what you want, probably. Furthermore, if you're expecting this to be a number, and then maybe, like, let's say that we're writing a piece of program to write how old you're going to be 8 years from now, okay? Let's do that. Now come back to what I wanted to say. So the job is this. We're going to write a tiny little program that is going to calculate how old you're going to be in 8 years. And to do that, it's going to take your current age. So basically a program to add 8 to your current age. Okay, as simple as that. So let us go ahead and do that, okay? So I want to keep this somewhere because it's pretty useful. So let's just put that at the bottom. Move this up. Okay. So, dear person, please enter your age. And then after you enter it, we are going to actually convert it to an integer so that we can do the math on it. So we're going to start using better names. So for the variable, so we're going to call this current age, and then we're going to call this future age. And future age is going to be the equivalent of converting the current age to an integer, and then adding to that 8 years, because again, this is predicting 8 years in the future. Or actually, let's make it even more interesting. How about we make it so that you can enter your current age and the amount of age you want to compute. So basically a tiny little calculator. That's a more interesting thing, okay? So first we're gonna enter our age, then we're gonna ask how many years you want, so future years. So we're saying years added, here's to add, and say, next, please enter how many years to add to your current age, okay? Something like that. Now you'll notice that this is really wide. So you're like, oh, I don't really like this. I would like this to be, 2 lines. Like, can I just put this here? But if you do that, you're going to get an error. So what can you do? Actually, it turns out that you can use your multi-line like that in this specific scenario and get around that issue. That's one way to do it. Another way that you could do this is you could do this into a string. So you could create a string first called like prompt. So you could say prompt and then just generate the string and then just print out that variable. Okay, so here, let's do that for this one. So we'll say prompt, so we'll call this initial prompt. And you can store what you want to print out there. And then here, instead of calling the string itself, you just call the variable like that. That's another way you could do that. And then you can have this more easily modified and make your lines a little shorter. Okay, so this is 2 ways of kind of cleaning up your code. This tabbing, however, is going to be ignored by Python because of the 3 quotes. Okay, so one way to do that, I suppose. Anyways, this will take the future age by taking the current age and then the years to add, which we also need to convert to an integer before we try to do anything with it. So we'll take current age, years to add, and now this is an integer. So remember, it's an integer because now we can't use concatenation for that. Okay? So when we go ahead and print out this value, we want to make sure that we use the comma for this. Or let us say that we wanted to keep it as an integer, and we still want to use concatenation. What can we do? Well, we can convert it back to a string. Just like you can convert things to an integer, you can convert them back to strings very easily. Whereas going into an integer is putting int and then quotes. If you would like to convert it to a string, guess what it's going to be? String quotes. However, you abbreviate strings to str, as you've seen earlier with the messages. So by doing that, it's going to automatically convert it. And now that it's a string, you're able to concatenate without problems. Okay? So I believe that's it. That is all we need. So let us go ahead and try to run our program and see if we have succeeded. By the way, I want to comment out this stuff here at this point. There we go. Just to clean up the output. Okay? Dear person, please enter your age. So I will say that I am 42 years old. Next, please enter how many years to... Ooh, snap. You see this? You see what we have just done here? We were able to fix the issue with the multi-line, but then we apparently broke by adding a bunch of characters. Didn't think about that. My bad. We'll fix that. And then please enter how many years to add to your current age. I will say please add 8 years. And now we broke it. Why did we break it? Oh, because I said bar 1 here. Apologies. I meant to say future age. But while we're at it, why don't we fix this issue? So this was not the way to go, definitely. So let us use concatenation to fix this issue. So let's have 2 strings. I mean, it worked, but like we added extra space to it. So I forgot that happens. So what we can do is we can use concatenation in here, like this. So this would work, but obviously we have the multi-line issue. So it turns out that when you have things in parentheses in Python, as long as you have a different operation happening and you're connecting them, then this will compile, or this will interpret without complaining, okay? And this looks prettier than the big line. You want to keep your lines short, easy to read. You don't have to scroll back and forth in addition to going up and down as you're reading code. So this is something to just make it easier to read, okay? So I believe that this will be good to go as long as we put a space here, or we could also put it here, just so that it doesn't stick years and two together, right? All right, run it. Dear person. Oh, one more thing I also saw is I want to put colons here and a space next to each of these, so it looks easier on the eyes. Okay. Dear person, please enter your age. Okay, I am 42. Next, please enter how many years to add to your current age. Well, please add 8. You are 50 years old. Have a nice day. Very cool. See, it all worked out. Let's try it again. In fact, let's try with a negative number, actually. Dear person, enter your age. I am 87. How many years do you have to your current age? Well, I would like to take away 7. You're 80 years old. So it actually works with negatives too. Whether or not you intended that to be the case is different, right? Which brings up what I wanted to say earlier about whether you or not you intended that to be the case. Let's say that person enters 54 here. Please enter how many years to add to your current age. And you say something like, please add 10 years. Thanks. And bam, you just killed the program. You just massacred the program. Look at what they've done to my book. How they massacred my book, right? What happened? Well, it was expecting a number and you fed it way more than just a number and it crashed. So this brings up what would be a harmless issue for you. However, it may not be so harmless for others. Turns out that this is what's known as not sanitizing your code, okay? So let's talk about what that means and what that entails in this world, day and age. You always want to sanitize your code for your sake and for your security's sake. Of course, in this class, you're doing data analytics. You're taking code or data that you know it's safe, and you're processing that data. So you're not particularly worried about a bad actor coming in and feeding you bad data, right? But however, a lot of the times when you're dealing with somebody else's data, it's not that clean. And what I mean by that is that you might get a spreadsheet where, like, one column is supposed to contain dollar figures. But then somewhere in like line 1 million or something, instead of having a dollar figure, it has a letter T because someone made a typo, something happened, you got something in there that shouldn't be there. The program tries to read that number, tries to convert it to an integer so it can do some math or float or whatever. Bam, crashes the program, kills it. Not good, right? Not good. And so this is unintentional. I mean, this is not a bad actor like some hacker trying to crash a program. It's just literally like a mistake that happens. And it's something that happens more often than you think. And so this brings up this big argument about you always want to be careful when you're doing things like converting data types to other data types or processing data, because you have to make this assumption that there might be invalid data, such as there might be a word where there's supposed to be a number, or there might be a negative number, or a 0 where there should be a number. So imagine like you're trying to do like a division of something. You're trying to divide how many, like, okay, you have data of items purchased and the amount purchased for, or the amount that they purchased. So like, for example, you have a store and they sell DVDs, right? And they sold 5 DVDs for Batman and 5 DVDs for Superman and 2 DVDs for Scooby-Doo and 0 DVDs for Inception. Okay, and so you're trying to figure out what is like my average of sales for like the Batman one, right? So you divide by the number that you sold, so by 5, You know, you sold some for $5, some of them for like $7 because price was up, or you had a sale going on at some point. So you're trying to find out the average you sold it for, right? It works for all of them. But when you get to the Inception one that sold 0 copies because they all sold on Blu-ray or something, then you can do division by 0, and if you ever done that in the calculator, you know that that causes a floating point exception. The program crashes in the case of Python, or because the calculator just dies. Not good again, right? These are all things you have to take into consideration. How do you do that? Well, there's a lot of things you can do. When we get to exception handling, like I said on last class, then that's something that you will have to put in the code to avoid catching errors. However, before you get to that extreme, you can check whether something is valid or not. In the case of division, you can check if a number is 0, and if it is, then you don't make the division. You put something else. Like you say no sales, so average is going to be 0. You put something to catch those kind of issues. Furthermore, for the problem with the Excel spreadsheet with the T, rather than just initially just trying to convert something into a number, you want to check what it contains. There are functions in Python that I'll show you when we talk about functions to check whether something is a digit or not. You want to run these functions like it's digit to see if what you're trying to convert to a number is actually a number. And if it is, then go ahead and convert it. But if it's not, then hold on a second, take a pause, and don't convert it. You know, figure out, work the problem, or skip it, do something. Handle it, basically, okay? That's the importance of sanitizing and cleaning up your input. I put sanitize your code, but I meant to put sanitize your input. Although you should sanitize your code too, frankly. But yeah, okay? So that's a very, very important concept. And in terms of data analytics, you will hear terms like tidy data or cleanup data. And it's a big step. It's a lot of work, actually, trying to clean up data to analyze it, because computers like things to be fed in a very uniform way. Fortunately, unless the data was generated by a computer, it is definitely not uniform or clean. Okay, it's a mess usually. So I would say that half the battle is just getting the data to be fed in and be processed cleanly. The other half is just doing whatever you're trying to do with the data. But yeah, it's a lot of work. Okay, that's why when you're searching for a data set, it's something you got to keep into consideration, like that the data is going to have some pre-processing done to it to be manageable. Okay, so that's one side of sanitizing. The other side is, of course, a bad actor. Maybe some of you have heard the term SQL injection and other potential cybersecurity issues, where you have to be careful, because if you allow someone to enter input into a system, like on a web page, you want to log in, you put in username and password, they are going to put something that is going to break your program if you're not careful. Like, they might not even intend to, but they might actually intend to. That's the one you got to worry about, right? SQL injection turns out that when you are feeding in information to a web page, sometimes that web page is connected to a database, and that database is going to process that data, like, you know, look for a username or something. And so you want to make sure that it's just looking for a username, not that it's actually taking what you entered and putting it into a piece of code that is then going to get executed, because then you're allowing somebody else to modify potentially what you're executing, right? With Python, there is a way that you can code your own function, so there is kind of a way to really, you know, exploit that. But I don't think we'll cover that, or if we do, it'll be way if you have a spare time. Just make sure that you're very careful about this, because people might put bad things in there that might exploit your program, break your program, crash it, intentionally or unintentionally. But majority of the time, it'll be, in your case with data analytics, it will be unintentionally because of non-cleaned up data. So either clean up the data really well, or you make your coding robust so that if it runs into an issue with something like a data conversion, that it knows how to handle it. And by handle it, there's not clean ways. So if you're expecting a number and you get a letter, you know, for like a sales for something, then it's clearly a mistake on the data end. So you're gonna have to either skip that line, ignore it, write it on the log and save it for later. There's going to be some sort of handling of that issue, right? Even if it just means ignore it. And of course, that will mean going back and seeing why that data is like that, yelling at somebody, whoever created the data. So there's no easy way, but it's much better than crashing, and then your boss is like, what happened? Well, all the work last night was lost because the program crashed because somebody had a T. They're gonna be like, come on, man. Like, you could have put something in there to stop that from crashing and like skipping it, right? So you don't want to be in that situation, right? So that's my spiel about sanitizing. Don't worry, it'll be not the last time that we talk about this. We'll talk about it more later on, okay? But that pretty much covers how to read input into a computer from the standard terminal, okay? Now we can move on to talking about reading input and writing output from files. Or two files, I guess, if you're writing. Okay? So, file I/O. In Python, there's a couple of ways, and I will put in the description below a link to the input-output of the documentation from python.org, but I'm sure there's also a Geeks for Geeks on this as well. And there's a couple of ways to open files in Python. So basically the mindset that you're going to come in when you're trying to read from a file is, the first thing is you got to locate the file. So ideally that file is going to be located in the same directory as your Python file. So if you have this is your code, and this is like a Python file, and you know it's a Python file because it's py, so this could be called like x.py or something. And ideally, you want this to be in the same directory as the file that you're working at. So we'll call this like file1, txt or something. If it's not to worry. You can put in the directory if it's in a subdirectory. So for example, if you have a folder called DA621, and in this folder you have your x.py file, but then you have a folder in here called data. Here, let me write that bigger. So data, and in that data folder you have a folder called 1, and in that 1 folder you have an actual file. Let's call it f.txt or something. It doesn't have to have a file ending, by the way. I'm just putting txt because that usually stands for text. If this is the case, then you need to understand how file directory systems work in your computer, whether it's Linux, Mac, or Windows. So in this case, when you're executing this, you would have to know that the file is located in data/1/f.txt. So that would be your directory. If you're on Linux or Mac on a terminal, you can type the word pwd to find out what the directory of your current location is. So you can work your way in a terminal to where the file is. Open the terminal there, otherwise, and then just type in pwd, and that is going to give you the entire directory path. If you're on Windows, I believe the dir command will do the same thing for you. So you can get that path that way, okay? But you only really care about finding the path from the Python executable to the location of the file, okay? So if you want things easy, just put them in the same directory. You don't have to worry about that. Otherwise, you have to understand this file path stuff, okay? So for now, we'll do the example where they're on the same file, okay? Just because it's the most basic one. So it's on the same location, all right? And this is whether you're trying to read or write. So the idea is that you want to, once you've located the file, you want to open the file. So locate file, that's your step 1. Step 2, open the file. And if the file does not exist, such as in the case of you're trying to create a new file, then that's okay. You just put the name that you want and open it, and it'll create it. Otherwise, if you're trying to open a file to read in, or opening a file to write to, like to append to or to overwrite, then you just pick that and open it. And then you can read or write. Okay, I would not recommend you do this both to one file. That's going to cause a lot of problems, major problems. Okay, so you either read from a file or you write from a file. Don't do both. Why would you want to do both? Like, that's just, yeah, okay. After you're done reading or writing to a file, then you want to close the file. Now, this closing of file, like if your program terminates, if your script ends, then it'll close the file for you. But it is good practice to close the file yourself, because you think about it this way: you're like holding that file hostage. Like, I'm working with this file, so you don't let other people touch it by using a file descriptor, which you don't really know what that is. And so you ideally want to release these resources as soon as you finish using them, even if your program is not finished yet, because there's no point. Somebody might actually want to write the file later on, so you want to be able to not run into issues where you're both trying to write to the same thing and bad things happen. Okay, but this is basically going to be the process: locate, open, do your I/O, and then close. Turns out Python can really combine all these things into like 2 lines of code, basically. Okay? In fact, technically 1 line of code, but then the processing or the reader writing is kind of its own line, so 1.5%. Okay? So I'm going to show you which one should I show you? I'm going to show you the short wave first. No, I'll show you the long wave first, and then the short wave. Okay? Well, long, but not really. Okay, because the long way is kind of more what other programming languages do, so it's a good thing to know as well. So, yeah. Okay, so let us go ahead and, make another file here. We'll call this Python 3. Okay, Python 3. Oh, damn. I did not add a file extension to this. Okay, let us make another one. Why not? I really should change the directory that I'm doing this in. I'm doing it in like desktop. Let's delete this one. There we go. Okay, I will delete that later. The other one, it's on the trash bin or whatever they call it. Okay, so yeah, let me just show you the process of doing this. First of all, let's go ahead and do the writing first, because now we can create some files that we can read later. Okay, so if you want to open your file, so again, locate, in this case, we're skipping that step because we are going to write to the same location as where the script is running from. So we don't need to worry about locate. We just got to pick a name of what we're going to do. So we'll just make it, okay? So we're going to create a variable. We'll call it variable f. And what that variable is you can think of it like a pointer to where the file is at. It's going to remember where the file is at so that you could refer to this variable whenever you want to work with the file, okay? So we're going to assign there a function called open, and this function open, as the name implies, opens a file. So you got to pass in at least 2 parameters, I would say, and those parameters are going to be the name of the file. So in this case, we're going to call it the da621.txt. That's the file we're going to open. In this case, we're going to create it because it doesn't exist. And then we got to pick what we're going to be doing to the file. So in this case, whether we're reading or we're writing. So we're going to say writing mode, okay? If you read the description here, it's going to give you so much information about this. So very fast, let's just go ahead in here and look at the modes for reading, okay? So mode is optional string that specifies the mode in which the file is opened. It defaults to R, so it means that if you don't pass in this W, by default, it's going to switch to read mode. So you're reading from a file, but we want to write to a file first, okay? I would always specify it anyways, because you want to be clear about whether you're reading or writing from a file. And even though the default is to read, not everybody may know that, and you don't want to make your code obfuscated intentionally. So just state it. It's not that much more writing, okay? And it also avoids confusion, which again is a big thing. So yeah, so W for write, R for read, and it's important to know that when we're saying writing, we are overwriting. So if that file did exist already, whenever we write to it, it's going to delete what is currently in the file, and then it's going to go in and create a new file, okay? If it doesn't exist already, or overwrite the one that exists. Now, if we wanted to append to an existing file, such as like, we're creating a log file, and we just want to store like the latest information from our program without overwriting what is currently there, we can use A for append, okay? And all of that is here in this documentation for us, so you don't have to remember it either, okay? So let us just stick to the write for now. Okay, now that the file is open, we can write to it. So how do we do that? Okay, very simple. We just write to it by calling the variable and then saying write. And it's kind of like your print function. So remember, imagine literally like print. So we're going to say, hello, this is a file. Okay? And then we can write some numbers in there. Actually, we'll see if it complains about the numbers like that. It might complain. Actually, we'll see. We'll see. Yeah, it's probably going to complain. I think we're going to need to convert those into a string. So let's see. I want to see it complain. Yep, it complained. So it wants us to only pass, every time we call write, unlike the print function, it wants one string. That's all it wants. One string. You can concatenate things together. Like you could say, this is A, and then file, because it concatenates them and still passes just one string. But in this case, it is complaining about this. So if you want to print that out, you can create a variable first, and then do whatever you want to that variable. So you can do math, or convert things to string afterwards. Whatever it is that you do, you want to make sure that this ends up as a string. And then you just throw in that in there, okay? And after you do that, then it's going to write to a file. Once you finish writing to a file and you want to close the file, you just do F-close and you're good to go. So if I run this program, and now I go look in my directory, here, you will see the file. In fact, here, let me delete it, just so that I run the program with no file. So I'll show you that it works. Runs, we go back and check, and it's there again. If we open it, we see, hey, oh, this is a file, 3 potato. Why 3? Because 1 plus 2 is 3, and it concatenated the word potato, so yep, it is correct indeed. If I run it again, you can see that it still contains, we'll hit reload, it still contains the exact same thing. It's overwriting it each time. That's why when I run it and I switch back to it, it says the file has changed on the disk, so it reloads. Let us switch to the append mode. Run it a couple of times now. 3, 4, 5. Oh, there we go, 5. Now, if I switch to it and I hit reload, I can see that this is running it multiple times. In fact, it's putting it on one line, which is annoying. So let's kind of put a line feed in here and then run it a few more times. Reload, and you can see that it still has the old ones, but it also has the new ones in there. Okay, so this is append mode. It's not overwriting, it's just appending. Switch back to W, run it once, reload, and it's all gone. Okay, so very important that you know the difference between append and write, because write, it will kill everything. Now, if you want an easy way to screw everything up, when you open a file, open the Python file you're running with, so Python 3, write to it, you just overwrite your entire program and you lost everything. I've had that happen to students. I don't want it to happen to you, so be very careful about that. Don't put your file name of the executable as what you're trying to write to, because you will literally overwrite your own code and the whole thing will die. Also, you should make backups in general of everything you do in life, so no exception for here. Okay, that's how you write. How you read is you can switch this over to R to read. However, let me, before I switch it over, let's copy this and put it in Python 2 at the bottom, just so that it's there. I like to keep reference of all the examples in case anybody has any questions or wants to experiment. So let us go ahead and switch this now to read. And now, of course, we don't want to write to that, but what do? We want to read into it, okay? Now, read is going to work kind of like your input. Of course, you don't need a prompt because this is a file, so who you're prompting to, but you need to store somewhere. So let's just say we're going to store this in bar1, okay? So what bar1 is going to contain is going to be the contents of the file, but not all the file. We'll see in a second how that works. And you can, of course, close the file after you're done reading from it, okay? In this case, we still have the DA621 file, so let's just read from that file, what we just wrote. This is the latest version of that, okay? So if I run this, why did I get this whole hello, this is a file thing? I think I forgot to save. Let me run that again. How am I getting this is a file? I guess that's from the file. Oh! Because I read from the file, actually. My apologies. I read from the file, so that's why I'm getting it. And then I'm printing it. So as you can see here, I am printing out what's in the file. So, yes, literally what I wanted to do. But I got confused. So as you can see, it's reading what looks to be the entire file. However, let's modify the file and put some stuff in here. In fact, I had a document with a bunch of stuff that I can just paste here. Okay? So now let's try this again. Notice that it read everything from the file. Okay? However, it's all contained within one single string. This can be kind of messy. Like it's just a blob of data in one single variable. This might not be the ideal way to read. What if you only wanted to read a single word? Or what if you wanted to read a single line? So there's a lot of more ways of reading than just read. You could do something like read line, as that implies that it's going to read a single line. So if I look in here, I'll see that it only read up to the first line feed or carriage return. There's also, once we talk about lists, a way of splitting. So even though you're reading a single line, then you can split that into individual tokens, which is very good for data processing. Tokens will be each word, so you can read one at a time. So we will revisit this, but for now, I'll stop there and say that you have read and you have read line, okay? So both of them are very useful to just read basic data, okay? So that's how you read and that's how you write to a file, basically. There's a better way, though. There's a cleaner way of doing this and that's going to be the with open format, okay? So if you look in the documentation the link is in the description below, you will see this with open system. So let us go ahead and try that out. So instead of having this, we write with open and then put in your file name like that, put in the same rules of read or write, whatever you want. So let us say we're reading, and then you put the variable that you will put with f equals open. You put it here like that with open sf and a colon. I know there's a lot of weird syntax for now, but it'll all make sense later on. Then you have to tab what's inside of this. But the advantage of using this with open system is that you don't technically need to close the file. You don't need to call that fclose function. And by the way, in the documentation, I'm seeing this, and I forgot to mention it. I guess if you're really curious if you opened or closed a file successfully, there's a variable called fclose, which will literally print out true or false depending on if the file was closed or not. So if I actually take back my old example here for read, and I don't close that, but then I print out fclosed like this, and then I comment this out, run this. Oh, it's not a function, it's an actual variable. Run it like that. Then and print it out so that we can see it. You will see that it says false because you haven't closed the file. But if I uncomment this line and close the file, it becomes true. Okay? So that allows you to see whether you close the file or not, I guess. But I mean, you might as well just close it and not worry about that. But now notice that if I do the same thing here, I don't need to call close, and it's actually closed. So this with open is a much nicer way of opening a file, whether it's for reading or writing. This will work for read or write as well. The only trick to this is that you have to know the syntax with open as f or whatever this variable is. Again, this is the variable you assign, just like we assigned before here. And you have to tab things, okay? In Python, this is a different scope, so you have to tab it. Press the tab key. So it cannot be flush. This will make more sense when we talk about the if statement, which I thought we would get to today, but we will save that until the next class. Okay? So that is going to be how you open and close files in one line of code. That's what I was trying to say. Just bam. You don't need to worry about open or close as long as you do it that way. So yeah, it's nice, you know. The Python's all about learning all these tricks to write less but do more with less code. So this is just a simple example. You can just as well use this with the F open and everything. That's perfectly fine. Will work the same way. It's just that this is a little bit nicer, a little bit faster in terms of writing. Just writing, actual code writing. Okay. So that's it. That's all I want to show for now, because I don't think we have enough time to really get into the if statement, and that's going to be a pretty long discussion to make sure that you all understand it. Lots of pictures and action. So we will save that for next time. Come on, go away. There we go. Okay. So again, I thank you all for watching, and I wish you all to have a good weekend, and I'll catch you around next time. Thank you, and have a great day.